Hello, everyone. We're going to get started. Just a reminder that this session will be recorded. Welcome to Sterling and VMware's Power Blocks session. I am Jenny Barber, and I am Sterling's marketing manager. We know your time is valuable, so we want to thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with industry best value on all of our client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master service competencies and more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal and state and local government contracts to support all industry verticals. Security is one of the utmost importance here at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email alias that you'll find at the end of the demo. For questions during the demo, please use the Q&A feature at the bottom of your screen, and we'll address all questions at the end. Now, I will turn it over to cloud architect Billy Downing to demonstrate automated application scalability with Tanzu Kubernetes Grid.
Awesome. Thank you very much, Jenny. I appreciate that. My name is Billy Downing. I'm a cloud architect here on Sterling's strategic services team. And today what we're going to talk about is VMware Cloud Foundation with Tanzu and how we're going to leverage Kubernetes to invoke some advanced features for our modern scalable applications using horizontal pod autoscaling and just kind of see how the solution works as a whole. So we're going to start off with a Kubernetes analogy just to level set what Kubernetes is from a very high level and generally what we're going to be using it for. We'll do an overview of what VCF on in our environment with Tanzu enabled, what it looks like and what that architecture will resemble. We'll take a look at what horizontal pod autoscaling is in context of a Tanzu Kubernetes cluster and just discuss how those different tools will look together. And then we'll go ahead and jump into a demonstration. And I'll be using the vSphere UI within VCF, as well as Octet to visualize my Kubernetes clusters. So we'll start off with a quick, kind of story of what Kubernetes is. And so what we're going to talk about here is we're going to start off from the left going right, and we're still going to start off with what we're going to refer to as a monolithic applications. We're going to use this as an analogy of you're going to an event and you're trying to provide guests with certain gifts. So say it's some sort of a potluck or some sort of a white elephant exchange where you have presents to bring several different people. So say you go to a store and you buy 5 or 6 gifts for 5 or 6 guests, and they give you all those gifts unwrapped in a single bag. So the issue here is when you show up to the party, you want to be able to give out your gifts individually and treat them as individual entities, and do whatever you need with it and have that scalability of giving those out when you want to. However, because they're all in the same package, your only option is really to hand them all out at the same time or have everybody use the same exact package. So they have a dependency on each other. So therefore all the guests that receive the packages are going to have to be in line and all of that good stuff that goes along with having one big bag to give out for an entire party. So your solution to that is going to be to take that apart. So you're going to take all of those gifts out of that individual bag and you're going to wrap them individually. So now you have the option of going to that same party. You have now 5 or 6 individually wrapped gifts. So you can hand them out and treat them as individual entities, and you can do whatever you need to do with them from that point forward. The problem here is that now you have a bunch of gifts that you're trying to understand how to kind of organize and how to correlate with all your different guests. So now you have, you've solved one problem, you've kind of created a new problem now that you have sprawling gifts coming out, and you're not sure how to manage all those gifts together. So to solve that additional problem, you use something like a platform, like maybe you have a centralized table, or maybe you have some sort of a loose space bag that isn't open once type situation, you could place all those wrapped gifts on that table or on that platform to have your guests go ahead and grab them, but in a way that you are offloading the responsibility of managing those gifts onto that platform or that table or that loose bag with all of those individually wrapped gifts. So at the end of the day, what I'm kind of alluding to here, trying to compare here is a monolithic application and going through that application modernization process as you go from having that single virtual machine or that single instance that has all of your processes, or in this case, all of your gifts, all of your processes running under a single control entity. And what that does is everything becomes tightly coupled, and all of the packaging according to that virtual machine must accommodate all the processes, and they all live and die together. And so what you have is an issue of monolithic application buildouts. So the first step to do that is we're going to break apart those different services or processes within that virtual machine, and we're going to individualize them into containers. That gives us the ability to deploy a microservice-based architecture. It gives us the ability to treat every service as an individual entity, so we can develop it in the language that best suits that specific role. And we can treat each service on its own lifecycle management control, so that we're not having to bring down the entire application if a single service needs to be updated. This also provides resiliency in general, understanding and knowing that a single service will not break down the entire application. It'll only bring down the specific application of that particular service or container in this instance. The next step, or the final step here, is using Kubernetes as that platform to manage all of those containers. When you start breaking down all the processes that go into an application, especially for a microservice-based architecture, you can quickly get into the scale of having hundreds or thousands of containers for a single application. It becomes very unruly to try to manage and orchestrate all of that. So Kubernetes comes in to act as that platform and orchestrate the complete lifecycle management, the deployment, and the scheduling of all of those different containers that you've deployed for your application, and deploys them in a unit called a pod. And it's basically just taking the role of that platform to ensure that you're offloading all that management overhead into Kubernetes, specifically in terms of how you're going to orchestrate that application microservices. So how do we get microservices or base architecture, or really how do we get Kubernetes into our existing vSphere environment? So assuming you have a VMware environment on-prem, and what we're going to be looking at today is VMware Cloud Foundation specifically, but this service is not just limited to VMware Cloud Foundation. This is also a service that is released with regular vSphere that you can deploy. So vSphere with Tanzu is another option. I just have the full suite of tools here, so we're going to take a look at those. So as a foundation from VMware Cloud, clean VMware Cloud Foundation, we're going to have an SCDC manager. In my instance, I have a VxRail manager as well. And what those provide is the orchestration layer for the entire cloud environment that I'm building out. So what SCDC manager is going to do is create a workload domain, essentially, which is going to be a platform for me to deploy all of my different services. And we can see towards the bottom here, the different control planes that I'm going to deploy in order to take care of and orchestrate all of these different assets. So starting from left to right in the bottom block there, we have our Kubernetes masters that are going to be virtual machines. Those machines are going to be deployed by vCenter and managed by vCenter Lifecycle Management. And that's essentially going to be our control plane for our Kubernetes architecture that we're going to kind of dive into in just a second. Following that, we have NSXT for our software-defined networking. So that's going to be not only our software-defined networking for our virtual machines in the environment, but also it's going to act as a CNI to invoke the software-defined networking requirement for our Kubernetes clusters as well. Then we have vSAN, or virtual SAN. That's going to be our distributed software-defined storage that we're going to be utilizing with this. And then finally, vCenter that orchestrates all of our compute resources from the virtual machine scheduling down to the actual ESXi hosts that are running the virtual machines themselves. Up top, just above that, our second layer is actually our workers, or our actual workloads will be held. That's going to be on our ESXi hosts. And so our ESXi hosts in this instance are also going to act as Kubernetes worker nodes. So just as vCenter is a virtual machine that's managing the ESXi hosts themselves for their compute and scheduling resources, our Kubernetes masters are also going to be virtual machines that are managing those ESXi hosts in a different way from Kubernetes perspective. So, and further up top, we can see that we can run vSphere pods as well as virtual machines side by side because they are managed by different controllers. And that gives us the ability to go ahead and have an architecture where we can deploy virtual machines that you are normally today and add in the capability to start running vSphere native pods as soon as you enable this. So you might be asking, how can I run a Linux pod on top of ESXi if ESXi is not a Linux platform? So what I'm showing here is what VMware has developed to solve that issue, and that is called CRX. It's VMware's container runtime, and that just gives a little architecture of what that runtime actually looks like. And essentially, what we're doing is creating a hyper aware virtual machine using a VMX file and putting in a Linux shim, so we have a Linux kernel to interact with, and then the containers are going to run on top of that. So this isn't directly or this isn't conformant with a Linux-based container running on bare metal. This is really a completely orchestrated, completely designed from the ground up architecture for a virtual machine to act very much so like a container. And so those are the vSphere pod service. But we also have the option of deploying TKG clusters on top of this in a virtual machine form factor. And so what this is doing is when you deploy these Kubernetes masters on top of your vCenter architecture, and this is all called a supervisor cluster, they're going to deploy components that are associated with Cluster API, which is essentially a project coming out of CMCF that is using Kubernetes to manage Kubernetes. So if we kind of go from the bottom up here, I have Kubernetes masters that are managing my ESXi hosts that are acting as my Kubernetes workers. And then on top of those Kubernetes workers, I'm actually deploying another virtual workload that is going to be a separate vSphere or a vSphere-based Kubernetes cluster, a Tanzu Kubernetes Grid cluster, which is also referred to as a guest cluster. Now, on top of this cluster, we can run native Kubernetes pods. This is running Photon OS. So this actually is a Linux distribution. So we're not having to do, we don't have to rely on a proprietary container runtime. Everything within this cluster is completely CNCF conformant. And this is just a way to allow you to use that base layer control form or that control plane in your Kubernetes masters, your NSXT, vSAN, and vCenter to control subsequent guest Kubernetes clusters to kind of release that burden of lifecycle management and things like that on each individual cluster itself. So at the end of the day, what you end up getting with this complete solution is a full platform as a service, essentially, that you can host your legacy virtual machines, as well as you can use to migrate some of those virtual machines into a Kubernetes-based environment for a cloud-native architecture. So how are we actually going to do this auto scaling aspect on top of these pods, or how are we going to actually take care of this from a perspective of automating the scale out of our application? So what we're going to be doing in this demonstration is we're going to be running these pods on top of a Tanzu Kubernetes guest cluster. And from there, we're going to implement what's called horizontal pod auto scaling. And so what that's going to essentially do is on top of that TKG guest cluster, we're going to instantiate a control loop. So HPA is going to instantiate a control loop and an API object from a Kubernetes perspective. And that's actually going to monitor our application utilization using a metric server that we'll also deploy. Based on the metric server component, so that metric server is going to monitor the compute and memory resources used for my application. And I'm going to set parameters within this HPA controller to dictate how I want scale to work from a CPU and memory utilization perspective. So what that actually comes down to is that I have a horizontal pod autoscaler that is managing or monitoring a metric based approach for my deployment, which is an embodiment of my application. And when that application shows spikes in CPU, the horizontal pod autoscaler is going to interact with it and scale pods up or down based on resource utilization. So what that essentially affords me is the ability to have an automated scale out architecture for my applications on top of vSphere running in a Kubernetes environment, so that I can scale in or scale out all of my applications based on demand without manual intervention. So I just want to tie everything together before we go ahead and actually jump into the environment. So what I'm going to show for today is I have an application deployment. It's a simple web-based, web-based front end that's running in a few different pods with a Redis server as a caching layer. So we're going to take a look at what that looks like in the environment today. And then we also have the metric server running. This is a Kubernetes conformant metric server. And this is basically deployed just to monitor compute and memory resource utilization within the cluster itself. And we'll take a look at how that's actually providing the API endpoint that the horizontal pod autoscaler is using to inform its decisions on scalability for my application. So the horizontal pod autoscaler is another object that we'll be creating inside of our Kubernetes cluster. And what that's going to do, we're going to set parameters of how much utilization we want to have expended per pod, and at what point we need this HPA to go ahead and scale that deployment either up or down. Finally, we're going to use Octant, which is a client-side visibility tool to see into our Kubernetes clusters to kind of visualize how this looks in the environment. And we can use that to also visualize the application actively scaling up and scaling down based on load that we're going to go ahead and throw at it. Okay, so we'll go ahead and jump into the environment. So the first step is that I want to kind of go over that first component that I talked about earlier, was that VCF component. So what I have here is a VMware Cloud Foundation environment. This is running vCenter 7.7.0 update 1. And what I can see here is that I have my 4 hosts, my 4 ESXi hosts, my vCenter, and then I have this namespace construct here. This is what you get when you enable Tanzu on your VCF cluster or your regular vSphere-based cluster. And within these namespaces, I have different architecture components that I can use to deploy my actual workloads in from a container perspective. We can see here that I also have my supervisor control plane virtual machines, and these 3 virtual machines make up the Kubernetes control plane that is dictating the scheduling for my Tanzu Kubernetes guest clusters, as well as all of my vSphere pods as they relate to my system in running either on bare metal on my ESXi hosts or running within those guest clusters. So I'll take a look at this namespace here. So this namespace is bdowning. And so what this actually does is give me a unit of kind of carving out some of my resources that I can go ahead as a vSphere operations administrator. I can create these namespaces and then allocate them to the developers. So developers have a self-service Kubernetes platform they can use to either build subsequent Kubernetes guest clusters using Tanzu, or deploy their applications directly on the ESXi hosts themselves using vSphere pod service. So if I look inside my namespace, I can see from a VMware administrator perspective, I have a lot of different options as far as how I'm going to permit who can actually access this environment. So who can access this namespace. So when they log into my cluster as a whole, what can they do in this namespace, and what permissions do they have? I can then also connect this to my vSAN data store to act as the CSI, or the container storage interface, to allow me to provision different PVCs or different storage entities to attach to my containers for things that I don't want to be stateless and I want to remain stateful. I can also go ahead and edit limits to this namespace as well. So say if I'm provisioning namespaces to a team of developers or a team of application owners, I can go ahead and create this namespace, hand them the access to it, and then go ahead and set limits so that I know that they're not going to overrun the resources that we've kind of allocated for them. And also within here, I have this object of a Tanzu Kubernetes cluster, and that is going to be those subsequent guest clusters that I have in here. So I have 2 clusters in this specific namespace, and we can see that they come with, this is going to be a virtualized control plane as well as virtual worker nodes. And these are seen within the greater supervisor cluster as managed Kubernetes objects managed by my overarching Kubernetes control plane that we can see here as these supervisor control plane virtual machines. Just to show you what it looks like as far as deploying vSphere pods directly on the ESXi hosts themselves. The indicator really is just this little icon here. So this is not actually a Kubernetes cluster. This is a vSphere pod running directly without running on a guest cluster. This is using that CRX, or that VMware developed runtime, to run this pod directly on ESXi host and controlled by my supervisor cluster Kubernetes control plane. So from here, I just kind of want to highlight a little bit more as far as the visibility that you get in vCenter in this, and the ability to have self-service automation for your developers as they're jumping into this environment, or they're trying to refactor their applications to run in a Kubernetes environment. So I kind of want to also show this for anybody out there who is the CLI fans, to show what does this look like from the perspective of once I the vSphere administrator, creates this Tanzu enabled cluster, and I allocate a namespace to my developers. I give them the link to go ahead and access this. And this is the same thing as giving a kubeconfig file to your users who are going to be addressing the cluster. And then I just go ahead and, from a developer perspective, I log into it using my credentials. And once I'm logged in, I have a kind of a cluttered keep config file, but I can see that I am allocated this namespace. We can also say I'm also allocated access for context for HPA, which is going to be the actual cluster that we see here. So first thing I'll do is just show from this perspective of logging into the actual cluster itself and viewing my namespace from a higher level. So I'll go ahead and use that context. And from my developer, what do they actually see as my resources that are available? So just like I can see from a vSphere administrator perspective, where I have my 3 control plane VMs and I have my 3 or 4 worker ESXi hosts, from Kubernetes perspective, I can see that I have my 3 control nodes that are made up of those virtual machines. And then I can see my actual hosts themselves are shown as Kubernetes worker nodes in this instance. And from here, I can go ahead and just take a look at the differences that are involved when we're looking at Tanzu being involved in this cluster. So we have this object that is a namespaced object. So within the context of my namespace, B Downing, I can create what are called Kubernetes clusters objects. So if I take a look at the objects that I actually have in here, I should have 2, because I do have 2 Kubernetes clusters, and I can determine how many workers, how many control plane nodes, the version, and the phase that they're in. And this is a way that I can use, just as you would lifecycle an application in Kubernetes on a normal day, you would lifecycle this cluster, this Kubernetes cluster, using normal Kubernetes normal object control for that. And what I was doing kind of in the back end here is just kind of showing that this is using the underlying project of cluster API. So if I, just to show those different objects that are instantiated in this, these are the objects that are related to cluster API. So Tanzu Kubernetes clusters instantiate the different objects that are shown for cluster API to have Kubernetes manage Kubernetes essentially. So if I were to go, and this isn't a Tanzu specific object, but if I were to get my machine deployments, this should match up with my Tanzu Kubernetes clusters, because these Tanzu Kubernetes clusters are matched and actually realized by these machine deployments that are controlled from cluster API perspective. Okay, so the last step we're going to do is actually introduce some load to our application. But first, I want to take a look at my actual cluster. So I'm going to log into my guest cluster now, which is under the context HPA. So now if I look at my nodes, I'm no longer logged into the supervisor cluster. Now I'm logged into my little guest cluster that I have sitting here. So this is running a different version of Kubernetes. And this is showing my control plane and my workers are completely separate from my my supervisor cluster over here. So this is a separately managed instance. You can use this for deploying new Kubernetes versions for testing, or this can be part of your process of migrating applications into a cloud native architecture. So another object that I have here is my HPA. So this is going to be the object that I was referring to earlier, is my horizontal pod autoscaler. And this also is going to be attached to my deployment, which is go figure FE. So if I look at this deployment, I can see that I have a simple deployment for go figure, which is going to be my front end. And then I have a back end or a Redis cache layer, and then a load generator that's just running an image of BusyBox. And finally, this is created, or this is my ingress is set up from a load balancer that is instantiated in my NSXT environment. So if I go over to this application and I make sure I can reach it, I should be able to reach it. And this is actually being hosted on a NSXT-based VIP that was created by Kubernetes. Okay, so now that we have that, I'm going to go ahead and start generating some load on this box here. And so while that's doing that, and essentially all I'm doing is creating a while loop from my BusyBox instance. And we're going to go take a look at, from an Octant perspective, this is an overview of the entire environment. So I just want to kick this off to make sure we see it happen. So the way I've set up this horizontal pod auto scaling is I have a go figure object. I can see load is starting to hit my entity now. When we previously looked at the pods that we had allocated for this environment, I had one pod running my front end, but I have this horizontal pod auto scaler monitoring the metrics of my pods. And when they reach above 10%, it'll allocate new replicas between a metric of minimum 1 to a max of 10. So we can see that I have now 3 replicas, which goes up from the single one that I had previously. If I take a look at my pods, I should see pods that are actually starting to come up as the load increases. So as load increases, we can see that this pod is actually only 35 seconds old. So these pods were dynamically spun up as a reaction to the load that I started generating in this application. And because my front end is a stateless application, because all of the data is held in my Redis cache layer, I can go ahead and scale this out without worrying about impact to performance or anything like that from my user base, because everything is going to be stored. This is a stateless front end that I'm developing for this application. So we can see now that there are more pods that are being deployed. So as load increases, it'll continuously add pods up to my maximum threshold of 10 that I dictated in my horizontal pod autoscaler. So now that we've kind of seen that happen, we can take a look at the different options that we have looking around using Octant to filter out what my application is actually looking like and how I can actually go about administering a Kubernetes cluster from here. So if we look at it from a Kubernetes perspective of a deployment, we can see my application metrics, what's going on with it. We can change the YAML that we have deployed. We can go ahead and control our complete environment from here. So what I'm going to do now is, now that we've seen our application actually scale out based on load, which now we can see there's 4 replicas going, and we can see that the utilization per instance is coming down. And I want this number, my target here is that no one instance should have more than 10% CPU load. So I set these purposely low so that I can go ahead and have this scale out quickly. And what I'm going to do now is cancel my load generation. And once I cancel my load generation, what we should see is that this number will actually start going back down to 0. And once it goes low enough, Kubernetes will actually dynamically start scaling my application back in. So that might take a little bit of time. So I don't know if we have time just to wait for that to happen. But the point of this is that I now have the ability, using this horizontal pod autoscaler and using a vSphere as a platform, is that if today you have virtual machines that are running in your environment and you're approaching the question of how do I make my applications cloud native, or a way that if I have a cloud plan in the future, how can I port those objects into the cloud and make them more efficient from a cost perspective? Having an application that can dynamically scale up and down is an absolute win from that perspective, because if you're paying by the unit of compute that you're utilizing, you only want to be using what exactly, or you only want to be consuming exactly what you need for your application performance. And so we can see now that this target is now back down to 0% since I've stopped the load. And pretty soon it will start actually lowering these replicas back down to my minimum of 1, because right now I don't have any load on my application. So that was sort of what I want to go through from a perspective of how do I enable automated application scaling on a vSphere type environment. And so kind of just to review everything we went through, what we've talked about here is a VMware Cloud Foundation environment enabled with Tanzu. And what that allows us to do at the end of the day is run our applications exactly as we have them today, without having to worry about refactoring everything. We can enable Kubernetes in our clusters that we have today and begin that process of migrating applications to a microservices-based architecture, or just simply into a container-based architecture for easier packaging of our applications and easier lifecycle management through a Kubernetes methodology. So what that allows is allow us to simultaneously care and nurture for our traditional applications that are running in virtual machines or even bare metal today, while giving us a platform just directly alongside it to start modernizing those applications to be ran in a Kubernetes type environment. That gives us some of those Kubernetes or those more modernized type of application features, kind of what we showed here in horizontal pod autoscaling. So that gives us the ability to scale out or scale in based on the application load, which can give you a cost benefit if you bill your resources based on utilization. It creates an application performance increase, because as load increases, there's no manual intervention required for you to increase the capacity of your environment. And it also gives us application resiliency in case we get any sort of, because Kubernetes is managing the lifecycle of this application in containers, it gives us that second ability to, if a container fails, it'll simply spin a new one up to meet the demands of our deployment that we've built out for this application. And with that, I'd like to see if there's any questions in the queue, but I want to thank you guys for joining, and I appreciate everybody sticking around.
Thanks, Billy. We did have a few questions come in. The first one here is, are you able to scale up instead of just out in this environment?
Yeah, absolutely. So that would be a different, so much like how horizontal pod autoscalers is scaling in and out, and it's an object that monitors the metrics. There's another object in Kubernetes called a vertical pod autoscaler that accomplishes a similar goal, except it will do the opposite, where it will scale up or down on a pod by pod specific schedule.
Okay, thank you. We did have another one come in too. Can you use other metrics instead of just a CPU and memory to trigger scaling?
Yeah, absolutely. So CPU and memory is by default what the metric server monitors. And so that's what I've used for this demonstration here. But if you have more advanced requirements as far as how you determine an application's performance, say, for example, it is determined by API requests per second or something like that, there are third-party tools that you can use to feed into the HPA or the horizontal pod auto-scaling controller to determine the load on the application, to determine what you want as your metrics for load base. So you can use a third-party solution to kind of send that scaler different metrics that it can use to scale up or down your application based on whatever custom metrics you want to use for that.
Okay, that looks like that's all of our questions for today. Thank you for joining us. If you would like to reach out, our contacts are here on the screen. We invite you to also look at our calendar at sterling.com for future events.